Nick Dabit doing a project for physics class. Thank you, everybody. Thank you. Thank you very much, everybody. Thank you. Thank you. The book I'm doing is called Angels and Demons. Angels and Demons is a 2000 best-selling mystery thriller novel written by an American author named Dan Brown, and it was published by Pocket Books. This novel introduces the character Robert Langdon, who is also the protagonist of Brown's subsequent 2003 novel, The Da Vinci Code, and 2009 novel, The Lost Symbol. I'm going to talk about the main character for a little bit. Robert Langdon was a professor of symbology at Harvard University and the main protagonist of the novel. He flew to CERN to help investigate the murder of Leonardo Vetra. He is described as wearing a pair of chino pants, a turtleneck, and a tweed jacket. His name is a tribute to John Langdon. I'm going to talk about terminal velocity. Terminal velocity is the state an object reaches when the force of drag acting on it is equal to the force of gravity acting on it. When an object reaches terminal velocity, it no longer accelerates. This occurs when a falling body experiences zero acceleration because of air resistance. The terminal velocity of Earth is 56 meters per second. Different objects have different terminal velocity. A person free falling has a terminal velocity of 56.08 meters per second, or that could be 124 miles per hour. The way to calculate terminal velocity is to calculate the drag exerted on the object, and then comparing that to the weight of the object to determine net force. The formula to calculate terminal velocity is v times the square root of 2mg divided by PAC. The v stands for terminal velocity, the m is the mass of the falling object, the g is the acceleration due to gravity, the c is the drag coefficient, the p is the density of the fluid through which the object is falling in. That's Robert Langdon's going to be falling in the Tiber River, and the a is the projected area of the object. Air resistance is air molecules colliding into a falling body creating an upward force that will eventually balance the falling body's weight. It will continue to fall at a constant velocity, which is known as terminal velocity. Newton's second law, which you all know, is force equals mass times acceleration, right there, and drag. As an object accelerates, the amount of drag increases. The formula for drag is right here. It's F equals 1/2 pu to the second power times CA. F is the force of drag, which is by the definition of force component and the direction of the flow velocity. P is the mass density of the fluid. U is the velocity of the object relative to the fluid. A is the reference area, and C is the drag coefficient, a dimensionless constant. The big question in this story is that real or not? I mean, it's not probable that it could happen, but it's very, very, very unlikely. I thought it wasn't real when I first read it. The citations or the sources are in the description, and once again, this is Nick Dabit, and this is my project. Thank you. Thank you, everybody. Thank you. Thank you. All right. Alright, that was my physics project.